Hi, in today's class, we are going to study the image formation by the spherical mirrors. We'll study how to draw these ray diagrams. Welcome to the class. So, as told in the introduction, we are going to see the image formation by the spherical mirrors by drawing ray diagrams. There is a particular way in drawing the ray diagrams. We used to by heart many of the ray diagrams without understanding how to do it. But in today's class, we'll see how to draw the ray diagrams in a scientific way. Whenever we draw a ray diagram, we'll use two rays to represent the light coming from the object. So we will always use two rays to represent the light coming from the object. First of all, let's see how to draw ray diagrams for the convex mirrors. Whenever we draw ray diagrams, please remember one thing. The reflecting surface of the mirror, whichever it is, its reflecting surface should be faced towards the left side so that the object can be placed there. So always we will keep the object towards the left side of the mirror. That's the first point. Again, we will always use two rays coming from the object to get its image. Always we will use two rays. Now, first of all, let's see the case of convex mirror where an object is placed at infinity. As I told you earlier, we'll use two rays. Infinity can be treated as a special case where both the rays will be taken parallelly. Whenever a ray of light is coming from infinity, we will say that parallel rays of light are coming and hitting the mirror. So here also, we have two parallel rays coming like this. First ray here and the second ray here. In the previous class, we studied that whenever a ray of light comes and hits the mirror parallel to the principal axis, it will go through the focus. Here, since it's the convex mirror, the focus is inside the mirror. We can see it there. The focus is inside the mirror. So, the ray of light cannot directly go and hit the focus. But the ray of light will go back in such a way that it seems like it's coming from the focus. Okay. So, the first ray, which is coming parallel to the principal axis, will come and hit the mirror and it will go back like this. We feel like it came from the focus. Second ray also, it's also a parallel ray. It comes and hits the mirror, then it gets reflected back like this. Here also, we feel like the ray came from the focus. So, when we analyze, both the rays are hitting each other. They are meeting each other inside the mirror at this particular point. That is the focus of the mirror. So, whenever we place an object in front of a convex mirror, at infinity, the image will be formed at the focus. You might be able to see this. There is a small image there which is formed at the focus. Because both the rays are meeting here and they are just making a small image there. That image is shown here. So whenever the object is placed at infinity, we'll have the image at the focus. And the image will be virtual and direct. We won't be able to get this image on the screen because it's formed inside the mirror. That's why it's called virtual image. Virtual images will be direct as well. It won't be inverted. Again, as you can see here, the image is highly diminished. Now we'll see what happens when we place an object anywhere in front of the convex mirror on the principal axis. In this case, the object is kept at infinity, very far away from the mirror. Suppose if the object is kept near to the mirror, anywhere on the principal axis, what will happen? Let's see. This is what happens there. You can see here the object is placed in front of the mirror on the principal axis, and as I told you, we'll take two rays. My first ray always I'll take parallel to the principal axis as took earlier. My first ray is here. As I told you, whenever a ray of light comes and hits the mirror parallel to the principal axis, it will go back passing through the focus. Here, since it's not possible, it will go back in such a way that we feel like the ray is coming from the focus. Now, second ray will be taken to the immediate next point that we have on the principal axis. Here, all the points are inside the mirror. Since it's convex mirror, we have the focus and the center of curvature inside the mirror. So we can't pass it through that. So the ray of light is coming, hitting the pole here, and from the pole it's reflecting back, following the laws of reflection of light. When we extend this ray of light inside the mirror, and when we extend this ray of light inside the mirror, both of them meet at a particular point here, where the image will be formed. So you can see here that in convex mirror, in both the cases, image is formed inside the mirror. It is always formed inside the mirror and it is diminished. So this is the speciality of convex mirror, that convex mirror always forms virtual and erect image which is diminished inside the mirror. So that's why convex mirror is used as side view mirror and rear view mirror in movies. So that whenever we observe through that mirror, it can cover a large area. It will form diminished images so that the mirror can cover large area. So whenever you study this convex mirror, please study this diagram carefully. It used to come for the exams. So first ray always parallel to the principal axis. As per the rule, it will go back touching the focus. Now here we feel like it's coming from the focus. Second ray to the immediate next point on the principal axis near to the object. Here the point is pole. So it's coming and hitting the pole. It will get reflected back, making equal angles on top and bottom of the principal axis. And both the rays, when extended inside the mirror, they will meet at a particular point here. So we'll get a diminished image. So if we keep the image, if we keep the object anywhere in front of the mirror, we'll get the image inside the mirror, mostly between P and F. It will be a virtual image, erect image, as well as diminished image. Now we'll move on to the concave mirrors. In the case of convex mirror, we only have two cases, in which this case is the important one. Usually we won't keep the object at infinity. When we keep the object at infinity, it will be very small. It will be highly diminished for us to see it. So usually in day-to-day life, the ray diagram that we consider is this diagram. So please focus on this diagram. Now going to concave mirror, we'll be keeping the object on different spots on the principal axis. Because in concave mirror, we have the center of curvature, the focus, the area between them, all that. So we'll see all that now. In the first case, as we told in the case of convex mirror, I am keeping my object at infinity. As I told you, when our object is kept at infinity, both the rays will be taken parallel to the principal axis. You can see the first ray here. The first ray is coming here. I'll just draw the arrow mark on it. My first ray is coming like this from infinity. It's hitting the concave mirror. So you know that whenever a ray of light comes and hits the mirror parallel to the principal axis, it will pass through the focus and come out like this. So it's coming out through the focus. Now my second ray again, it's drawn parallel to the principal axis. It will also come, hit the mirror, and then it will also pass through the focus. Like that. So now my object is kept at infinity and I got my image on the focus. As you can see, it's very diminished. It's very small. So in concave mirror, when I keep my object at infinity, I'll get my image at the focus. As you can see, it's highly diminished. So if the object is at infinity, image will be at the focus. It will be real and inverted. You can see, I don't know whether it's visible or not. It's very small. It's highly diminished. But still it's inverted, it will be upside down and it will be real and it is highly diminished. We'll go to the next one. Now first we kept the object at infinity. Now we'll bring it little closer to the mirror. In the next case, I'll bring it closer to the center of curvature. We'll usually say it like beyond C, beyond center of curvature. Let's see that case now. So now I have kept my object beyond C. So my object is beyond C. It's next near to the C. That's all. As I told you earlier, here also we'll be using two rays. First ray parallel to the principal axis. So my first ray is coming and hitting the mirror. It's parallel to the principal axis. Whenever a ray comes and hits the mirror parallel to the principal axis, it should pass through the focus. So it's passing through the focus. So it's coming and passing through the focus. Now, second ray, as I told you, it can be taken to the nearby point, the principal axis. So here, this object is here next to C. So C is the nearby point. So I'll make my ray of light pass through the center of curvature itself. Okay, so my ray of light is passing through the center of curvature. We studied earlier that if a ray of light is coming and passing through the center of curvature, it will go back to the center of curvature itself, because a line connecting center of curvature and the aperture of the mirror is its normal. So it will go back as it is. So here it will just go back. So first ray parallel to the principal axis will go through the focus. Second ray coming through the center of curvature will go back through the center of curvature itself. Let's see where are they meeting. So both the rays, first ray is coming and hitting this ray here. It's getting reflected back and it is also hitting here. Both the rays are meeting here. So we got an image here. As you can see, the image is again real and inverted. So when we place a screen here, we will get the image on the screen. That's why it's called real image. In the case of convex mirror, we won't get it like that because it's virtual image. Here, if we place a screen there, we'll get the image clearly on the screen. If you're using a candle to do this experiment instead of I have shown a tree here, instead of tree, in real life, if you're using a candle for this experiment, you can see the candle flame, but the flame will be upside down in the image. So when we place the object beyond C, we will get the image between C and F. Here also, the image will be real and inverted, and it is diminished. Compared to the object, we can see that the image is small in size, so it is diminished. Let's see the next case. Now, as I told you, I'm bringing it closer to the mirror. Now, I'll take my object to C. Now, it is beyond C. In the next case, it will be on C. Let's see what happens. Now, my object is at C. As I told you, the first ray will be parallel to the principal axis. I took my first ray. It should pass through the focus. It is passing through the focus. Now, my second ray should be through the immediate next point. It's already on C, so I can't make any ray through C. So I'll make a ray through the focus. So my second ray is through the focus. It's coming, hitting the mirror. Whenever a ray of light comes through the focus, it should go parallel to the principal axis. That's the rule, opposite of this one. So now, ray of light coming through the focus will go parallel to the principal axis. It's going. So my first ray came like this, it went like this. My second ray came like this and went like this. Both the rays are meeting here, which means whenever my object is placed at C, at the center of curvature, I'll get my image also at C. This is an important point on the principal axis, that is center of curvature. Because whenever we place the object on the center of curvature, we'll get the image also on the center of curvature. One more main point is the size of both the object and the image will be same size. Only thing is it will be inverted, real and inverted. If you place a screen there, we'll get the image. That's it. So when we place the object at C, we will get the image at C. It will be same size, it will be real and inverted. That's it. Now we'll go to the next one. As I told you, we are bringing it closer to the mirror. So now it is at C. In the next case, we'll place it in between C and F. Let's see what happens. Now I have kept my object between C and F. I'm taking it closer to the mirror and I'm keeping it in between C and F. As I told you earlier, first ray parallel to the principal axis is taken. It should pass through the focus, so it's going like this. Now, my second ray should be taken through the immediate next point. We have 2 points here, that is center of curvature and the principal focus. I can make it pass through any of these. It's my wish. If I make it pass through the center of curvature also, I'll get something like this. My ray will be going, hitting the mirror. My mirror is short here, so I should extend it here. So it will just go like this and come back. So my image will be formed somewhere here. Now I just made it pass through the focus. It's your wish, you can pass it through any point. I am making it pass through the focus here. So it's passing through the focus. After hitting the mirror, it's coming parallel to the mirror. So my first ray came like this, it went like this. My second ray came like this and went like this. Both the rays are meeting here at this particular point. That is a point beyond C. So when I place my object between C and F, I'll get my image beyond C. As seen in the slide, it is clear that the object is small but the image is large. So from this point onwards, your image will be bigger in size. So here, if the object is placed between C and F, your image will be beyond C. This one also will be a real image and inverted image. If you place a screen there, you'll be able to get the image. So it's real and inverted and it is enlarged. As you can see, it's enlarged. Now let's see what happens if we bring it much closer. The next point is an important point, that is principal focus. Let's see what happens once we place this object on the principal axis. Come, let's see. Now I have placed my object on the principal focus. So my object is at the principal focus, on top of the principal focus. As I told you, first ray can be taken parallel to the principal axis, but here, since there is much small gap there, it won't be visible. That's why I haven't taken that. If you want, you can take it first ray parallel to the principal axis. Then it will come through the focus itself. It will come like this. A line parallel to this line will come there. It's your wish. Now here what I have done is, I have taken the first ray towards the point which is near to that is pole. So my first ray is coming like this. It's hitting the pole and going back, making equal angles on top and bottom of the principal axis. Now my second ray I have taken through the next point that is near to it, that is center of curvature. I made the ray pass through the center of curvature. As we know, the ray will come back through the center of curvature itself. So it's coming back like this. So both the rays are here and both the rays are not meeting anywhere. That's important about this. If you are placing a screen there, if you have a candle, if you are keeping a candle here and if you are keeping a screen to get its image, we will feel like the image is coming. It's about to come on the screen. It's not clear. Okay, maybe it will be clear after some time. We'll take it back, 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 but it won't be visible at all. We'll keep on moving backward, but still it won't be that much clear for us, which means the image is formed. We can feel like it's inverted also. It's highly enlarged also, but we won't be able to get it. We'll have to move still backward. So actually here, when the object is kept at F, the image will be formed at infinity. That's why we won't be able to get it. But still, when we say the property of the image, we'll say like the image is formed at infinity, it is real and inverted, and it is highly enlarged. We'll say like that. So here, first ray, if you want, you can take it parallel to the principal axis also. It will be like this, a parallel ray like this. It will just go like this through the focus. But here, I haven't taken because this line won't be visible. If you want, you can take like this also. Anyway, both the rays will be parallel. Or you can do as I have done here. First ray through the pole. It will come back making equal angles on top and bottom. Next ray through the center of curvature. Both will not meet anywhere, which means the image is formed at infinity. Even if we extend inside the mirror also, we won't be able to get the image. We can't get it here inside the mirror, or we can't get it here also outside the mirror, which means the image is formed at infinity. Now we are taking the object much closer to the mirror. Next point is between P and F, between the pole and the principal focus. When I keep my object here, as I told you, I am taking first ray through the immediate next point, that is through my pole. So first ray is coming through the pole. If you want, here also you can take first ray parallel to the principal axis. It's your wish, doesn't matter. But here, if you take the ray parallel to the principal axis, my ray will be going like this. Then after reflection, it should come through the focus. But while coming through the focus, it will cut my object here. So the ray won't be able to reach here. That's why I'm not taking that ray. Okay. So my first ray, I'm taking it, come and hit the pole. After hitting the pole, it will go back making equal angles on top and bottom of the pole, of the principal axis. So I am taking my first ray coming and hitting the pole. So my first ray will come like this, it will hit the pole. After hitting, it will go back making equal angles on top and bottom of the principal axis. Now for me, to complete my ray diagram easily, the easiest way is to make it pass through the center of curvature. Because if I draw a single line, my ray will be over. So I'll just make it pass through the center of curvature. It's coming through the center of curvature. When we draw, we have to draw like the ray is coming to the center of curvature and hitting the head of the object. So afterwards, it will go back through the same path itself. So first ray came like this, went like this. Second ray came like this and went like this. They are not meeting anywhere in front of the mirror, which means they might be meeting somewhere inside the mirror. We don't know where they are meeting. So we'll just extend the lines like this inside and even this reflected ray will extend it inside, we'll see that both the rays are meeting somewhere here inside the mirror. So as you can see, in the case of concave mirror, this is a special case. When we keep the mirror very much close to our face, we'll be able to see our own highly enlarged image. If we place the concave mirror very much close to our nose, we'll see an enlarged nose. Once we place it far away, we won't be able to see it like that. Because in all those cases, we'll be getting the real image on the screen. If you place a screen here, we'll be able to get the image. But in this case, we won't be able to get a real image, but a virtual image which is highly enlarged will be formed inside the mirror. That is this case. So, when you keep the object between P and F, in the case of concave mirror, we'll get a virtual and erect image inside the mirror. That is highly enlarged. So, this is a special case. So, concave mirrors can give you all types of images. It can form real and inverted images. It can form virtual and direct images. It can form the image of same size, diminished size, highly enlarged size. All types of images can be formed by concave mirror. But coming to convex mirror, it can only form one type of image, that is virtual, erect and diminished image. Now we'll just revise what we have studied in today's class. In the case of convex mirror, we only have two positions where we keep the object. One is at infinity. When we keep the object at infinity, we'll get the image at the focus, but the image will be highly diminished. Now, next one is we can place the object anywhere on the principal axis. When we keep the object somewhere, wherever we want on the principal axis, we'll get the image between P and F. In this case also, object will be diminished. So in the case of convex mirror, this case is an important case which is practically applicable in day-to-day life. So even if you place your object at infinity or on the principal axis, we'll always get the image inside the mirror, which will be virtual and erect. So in convex mirror, we'll always get virtual and erect images. Now going to concave mirror. In concave mirror, we'll be placing the object at different spots. First we'll place the object infinity, then we'll take the object beyond C, then we'll keep the object at C, then we'll keep it between C and F, then we'll place it at F, then we'll place it between P and F. We'll see what happens in all the cases. When we keep the object at infinity, we will get an image at the focus. But during this case, the image will be very small, it will be highly diminished. But still we'll get a real and inverted image at the focus. Now, bringing the object near to the mirror, we'll place it just beyond C. During that time, we'll get the image between C and F. We'll get an image between C and F. Now, please remember that the image size will be bigger. At focus, the image size will be very highly diminished. It will be very, very small. Remember one thing, whenever we take the object closer to the mirror, the image will come away from the mirror. First, it will be at the focus. Now, it will go away from the mirror. So, one more thing, whenever we place it closer to the mirror, the image will be going away from the mirror, and at the same time, the size of the image will become bigger and bigger. It will get enlarged. Remember that one. When we place the object at infinity, we'll get the image at focus. When we place the object beyond C, we'll get the image between C and F. It will be enlarged. It is diminished than the object, but enlarged compared to the image that we got on the focus. Now, I'm keeping my object at C. I'll get my image at C itself. Here, both the size will be equal. Now, I'm placing my object between C and F. I'll get my image beyond C. It will be enlarged than the object. Again, I place my object at F. I'll get my image at infinity, which won't be much visible to us. But again, it is a real image and inverted image. Now, I'll place my object between P and F. This is a special case where my image will be formed inside the mirror. So in this particular case, I'll get my image inside the mirror, and my image will be enlarged image. It will be a virtual and erect image. That's it. So if my object is at infinity, I'll get my image at focus. If my object is beyond C, I'll get it between C and F. If my object is at C, I'll get it at C itself. If my object is between C and F, I'll get my image beyond C. And if I place my object at F, I'll get the image at infinity. In all these cases, the image formed will be real and inverted. In the final case, when I keep my object between P and F, I'll get a virtual and erect image inside the mirror. That's it. I hope the representation was helpful for you to understand how to draw the ray diagrams. Always will be a sure question regarding this ray diagram. So please do study this ray diagrams properly without by hearting. Understand how to draw the ray diagram and draw it. Please comment below whether the session was helpful or not. Now in next session, we'll see how to draw the ray diagrams in concave and convex lens. Let's see what happens in lens. Thank you.